Solving trig equations using a calculator. I believe the topic name in Alex is solving basic trig equations using a calculator, which makes me laugh because it sounds like what a simple topic, what an easy topic. What a misleading name is what it is. This is, I would say, the most difficult topic in this section. It takes some thinking through, and you need to use your knowledge of trigonometry to its fullest here. So here's the idea. You are finding solutions in an interval, so just concrete solutions. You don't have to worry about the plus 2 pi k. But instead of the equation having some kind of value you can actually find on the unit circle, it adds something weird. So for instance, maybe you have something like cosecant of theta equals 100 over 53. And if you rewrite it in terms of sine, you get sine of theta is equal to 53 over 100. You could also say that this is the same thing if you were to plug this into a calculator as 0.53. I only mention that because I'm going to use that value down below. This is, oh, my computer is upset at me. Hold on a moment. All right. So this right here, this value is not on the unit circle. There is not like a place on here where I can say, oh, the y value is 0.53. So you have to use a calculator. And this becomes a little tricky. This becomes tricky because, scroll down to this little picture here. What I have highlighted here in orange is the range of sine inverse. Range of sine inverse. It will only output angles between negative pi over 2 and positive pi over 2. That is the range of angles. So you could say, well, I can tell you what angle this is, that theta is. I'll just do inverse sine, right? And ignore this reference angle comment for just a moment, right? If I was being smart about this, I would say, well, then theta is equal to sine inverse of 0.53. And that would be my answer. And that is going to be potentially one of our answers. This one will be one of our answers. But that's not the full story. First of all, if this were a negative sign value, our answer would then end up, what would be shot out of the calculator would be an answer between negative pi over 2 and 0. And our answers have to be between 0 and 2 pi. So this has the possibility of shooting out an answer that doesn't even exist within our interval. Moreover, here is the y value 0.53, right? Which is what we said we wanted the y value to be. We wanted sine to be 0.53. You can see that y value happens right here on the unit circle, but it also happens over here on the unit circle, right? It happens in two places on the unit circle. And there's no way that this is going, that the inverse sine function is going to spit out whatever angle it takes to get to this guy, because it will only spit out angles between negative pi over 2 and pi over 2. So the game we end up playing here is looking at the range of the inverse functions, which are different between sine and sine tangent have the same one, cosine has a different one. We have to look at those ranges of the inverse trig. And then we have to think about what sine is, what cosine is, what tangent is, and where their other angle can be found on the unit circle. So there's, two places on the unit circle where the y value is 0.53. How can I find this other one? And we will be using extensively the idea of reference angles here. So if both of these angles have that, like the same coordinate point with different, negative positives, right? But the values are the same, 0.848, 0.53. There is symmetry on the unit circle. So if you were to do sine inverse of 0.53, it would output this very first angle here, because 0.53 is a positive number. It's going to output that very first angle here, theta 1. And whatever this angle theta 1 is, that same amount of distance right here will be the distance between the x-axis and this end of theta 2 over here. It's a reference angle is what it is. Theta 1 becomes a reference angle that allows us to find this second value over here, right? If this one came out of the calculator, which is great, then the second one, which is over here in quadrant 2, The second one in quadrant 2, I can find that because I know that from here to here, that's, well, other direction, right? This is pi. And then if this right here is theta 1, that makes theta 2 equal to pi minus theta 1, right? You take pi and you'd subtract off theta 1. And I know my headphones just made a really upset noise at me, and I hope they don't stop recording audio. Hopefully we can get through this video. So that's how you would find theta 2 here. First angle is going to be the reference angle here. You're going to get it from just doing sine inverse. You get 0.56. Keep in mind, these are in radians. You're not on 0 to 360. You're doing this in radians. So these angles are going to look a little bit sillier. And then to find that second angle, theta 2, you would subtract this reference angle, which is 0.56. But you want to use the exact values. Make sure you use exact values. I'm going to say to not round any intermediate computations. So using that exact value, you get theta 2 is equal to 2.58. Pi minus this angle here, theta 2, theta 1 is 2.58. All right, so this game gets complicated, and I've made some pictures here to kind of help you through it. You're going to not be able to use this chart on a test, so you do. My headphones are just screaming battery low at me. Hold on.
All right, so it's going to be a little more echoey. Sorry, I have a large area with echoey walls around me. My headphones are dead. We're going forward. This chart you will not be able to use on tests, but you can and should use it as you're beginning this topic and trying to figure it out for yourself. It can help to have something to look at before you really internalize the pattern. Understand that what is available to you here will not be available on a test. So I have made a chart of all the different types of scenarios because the scenarios, they start all like this. And so I'm just going to talk about the soulmates, the main cast, sine, cosine, tangent, but you can relate it to, the soulmates. You have the possibility that you have sine of theta equals a positive number, and that will output, right? If you have sine of theta as a positive number, it's going to output an angle in quadrant 1. You could have sine of theta be a negative number, and then your output of your original angle is going to be a negative angle in quadrant 4. You could have, and then it's the same thing, right? Cosine of theta could be a positive number. It could be a negative number. And tangent of theta, the same idea. It could be a positive, it could be a negative, and there's different things that'll happen for each and every one of these scenarios. That's what's going on here. I'm going to do a teeny tiny bit of highlighting here. I'm going to make the signs I'm going to highlight them in pink. Well, maybe I won't highlight that part, but I'll highlight them in pink. I'm going to highlight cosine in blue just to kind of help. I wish I had color coded them differently in the future. I might recolor code this. So if you're watching this video and you're like, Professor Cook, the worksheet looks much different than that because it's already color coded. That is because future me has done current me a service. All right. So let's kind of go through each of these, fill out this chart, and then do a few examples. This video is probably going to be a longer one, but it's worth paying attention to. All right. So if sine of theta is a positive number, we already said the first angle that's going to be output, the green line is the first angle. The green line is the first angle. The blue line is the second angle. The first angle that's going to be output is going to be in the right quadrant. It's going to be in quadrant 1 between 0 and pi over 2. So you can just do sine inverse on that number, whatever number that is, to find that first angle. Below each of these, I have put a reference problem. So sine of theta equals 0.468. That's just a random problem. So to find this reference angle, you just do sine inverse of it. The reference angle and the first solution are the same thing. Are the same thing. So the first solution is going to be here in quadrant one. Let me just I'll use a black pen for this. Is going to be here in quadrant one. This will be theta 1. So we have a quad 1 solution. And the other answer, right, where are the two places where the y value equals this positive number, the other solution is going to be the other place where y is, the other quadrant where y is positive in quadrant 2, somewhere over here, theta 2. So the answer ends up in quadrant 2. You have solutions in the first two quadrants. That's where your solutions will be. Hold on, let me please make a square. Come on. Make a square. There you go. Oh, weird. Why is it a different color blue? Who knows? Strange. All right, I'm just not going to worry about that. It's very silly. I don't know why it's making the color like that. Come back here. I'll just highlight. One solution in each quadrant is the big idea here. The first angle will just come straight out of it. With sine of theta equals a positive number, your first angle is the reference angle. And so your first answer here, just sine inverse of whatever number. The second angle, you use the fact that this reference angle right here, again, we just did a problem like that, right? That is where that reference angle is. So theta over theta 2 becomes pi, which is the entire distance there, pi minus this reference angle. The reference angle and theta 1 are the same angle. If sine is a negative number, then there are two quadrants where y is negative, quadrant 3 and quadrant 4. So your answers are going to be 1 in quadrant 3, 1 in quadrant 4. The reference angle, well, the value of it is going to be, when you get this first angle here, because again, this is the range of sine inverse. When you get this angle here, it's going to be negative because sine inverse goes from negative pi over 2 to pi over 2. This will be a negative number. You'll take its absolute value, and that guy becomes the reference angle. The absolute value of this becomes the reference angle. So, I guess I didn't. Oh, no, we're good. We're good. So the example problem here, sine of theta is equal to negative 0.25. The reference angle itself is the absolute value of that. I don't put an actual number here because you're not supposed to round these problems till the very end. Our two angles are, the first angle that comes out, first of all, it's going to spit out that negative angle, which isn't going to work for our answer. The first angle we need goes all the way around like this and ends itself in quadrant 4. And then the other angle with that same y value, theta 2, ends in quadrant 3. So for these ones, for sine equals a negative number, you'll have two answers, one of them in quadrant 3, one of them in quadrant 4. Quadrant 3 and quadrant 4 answers. To get this first angle, right, when it shoots out an answer, when you initially find this angle here using sine inverse, you use sine inverse, you get a negative number. You take the absolute value, it gives you a reference value, a reference angle. If you know what this reference angle is, that reference angle exists right here. This is the ref, theta ref. There's the reference angle. So you just take 2 pi and subtract the reference angle, right? And that gives you the leftover bit. So you can see that happening right down here. And then to find this guy here, everything is reference angle. That's the big idea. Basically, any acute angle you see is probably going to be the reference angle. So right here, symmetry is great. Theta ref is right here. So you know it's pi plus the reference angle pi plus the reference angle. And that gives you theta 2. Cosine is a little bit different. The thing that's with a cosine, oh, maybe I should have made these. Maybe, hold on just a sec. All right. To better match my color coding, I swapped my color coding here. I'll make these blue and I'll make cosine pink so that I can color code nicely. With cosine, the range of cosine inverse is from 0 to pi. So it's a slightly different range. All of those angles are positive, which is wonderful. Still, if cosine is a positive number, we know that the two quadrants where x values are positive are going to be quadrants 1 and 4, the right-hand side of the coordinate plane. And so there will be two places on the unit circle where cosine is equal to this value. The first one, that one's going to come straight out of cosine inverse. You take cosine inverse, it's going to spit out this green angle right away. That green angle is also going to be the reference angle. It's the reference angle and it's your first angle. And you can see it right here. Theta 1 is just the reference angle. Just take cosine inverse of the number. The second angle down here, again, you're using a lot of reference angles here. Whatever this angle is, that's the reference angle. And it's the same angle down here because these guys have the same x value. So it means that these angles have to be the same angle. So what do we do? Well, we know the whole way around is 2 pi. So take 2 pi, subtract out the reference angle, and there it is. Take 2 pi, subtract out the reference angle, you got it. So let me just draw these in real quick. The first angle, nice. It's just right here. This is theta 1. It is also the reference angle. It is in quadrant 1. The next one will be in quadrant 2. Or not quadrant 2. In quadrant 4. This will be theta 2. It ends in quadrant 4. So we have quadrant 1, quadrant 4, and as a highlight, let's see. These two quadrants. Those are the answers are, right? They're in those two quadrants. I can move you just a tiny there. Again, there's an example down below here, so you can see what those answers would come out to be if you had cosine equals 2/3. If cosine is negative, that means the x values are negative. The negatives are on the left side of the coordinate plane. You have 1 here in quadrant 2, 1 down in quadrant 3. The quadrant 2 one is nice because it's just spit out at you. It just comes straight out. It's really nice. Whatever is spit out when you do cosine inverse, that's the answer. So if cosine of theta is equal to negative 0.7, then you just do cosine inverse of negative 0.7. There's your first answer. Just comes straight out of it. So it's up here. This is theta 1, easy to find. It's in quadrant 2. That other angle down here in quadrant 3, this is the more challenging thing. So you need to find a reference angle first because, like I said, everything's about reference angles here. Whatever this angle is right here is the same as what angle is going to be here. So if I know what theta 1 is, then I can find the reference angle using the fact that this is pi, this is theta 1, pi minus theta 1. So really, pi minus cosine inverses of the number is what ends up being. That ends up being your reference angle here. Once you have this reference angle, pi plus the reference angle gives you theta 2, pi plus the reference angle. And that's in quadrant 3. There's a quadrant 2 answer and a quadrant 3 answer. Boom. Part of me wants to make these lines just thicker, just to like, woo, look, there they are. Yeah, maybe I should have made these pictures a little bigger. Those two answers. Maybe do that on your paper. Okay, just go do that. Make these lines thicker. make sure that it's very visible. Any visuals you can give yourself on this section are going to help. The really key thing, and I think you can see this, is understanding the ranges of the inverse trig functions, and then understanding, all right, sine is a y value. The y values are going to be the same if I draw like a horizontal line. So there's a spot here, then we'll have the same y value over here, and then understanding reference angles. That's it. It's, okay, where are my answers at? What is my reference angle? What angle was output when I did the inverse trig originally? And using all those pieces in creative ways. For these tangent ones down here, tangent's a little bit different. So like their values are going to be the same directly across the unit circle from one another. So if tangent's equal to a positive number, this is great because much like with sine, you're going to get a positive angle here. Tangent as well as sine inverse, their ranges are from negative pi over 2 to pi over 2. So it's nice when it's a positive number because that's in quadrant 1. The reference angle is the same as the original angle. So you have this quadrant 1 angle. And you just get that from doing inverse tangent. Q1. And then you have down here in quadrant 3, the other angle, Q3. We know that this angle here is the reference angle. Theta 1 is the reference angle. So this angle here and this angle here are the same. So to find my second angle, I need to take pi and add the reference angle. Pi plus the reference angle. Again, do whatever it takes to make this visual for you, to help you understand what's going on here. The last one, if tangent is equal to a negative number, then you have a solution. So your first solution will be down here between negative pi over 2 and 0. So it won't fit within 0 to 2 pi. In order to find the reference angle, which will be this angle right here, you'll need to take the absolute value of what you get out because whatever you put in is going to come out to be a negative number. The absolute value of that ends up being the reference angle. The first angle that we care about is going to be this guy that's theta 1, the first guy that's spit out over here. We are going to be given this angle to begin with. Two ways to go. You could think of it as taking tan inverse and adding 2 pi to find a coterminal angle, or you could think of it as, okay, this whole circle is 2 pi, subtract out the reference angle, which is right here. This is the reference angle. And you are left with theta 1. So there's that one in quadrant 4. And then in quadrant 2, this is theta 2. This guy right here is the reference angle. So if you take pi and you subtract out the reference angle, you're left with theta 2. Oh no, this should say minus right here. I have it right here. Here, fix this. Actually, I'll fix it. So hopefully when you've seen this worksheet, it is fixed. I'm gonna fix that right this second before I forget. Come here, Paul. All right, I'm saving that. So yours should look correct. And there's theta 2. Your solutions end up being here in quadrant 2 and quadrant 4. Boom. There they are. All right, so let's kind of see this in action. Let's see this in action. Use a calculator to find all solutions in the interval 0 to 2 pi. Do not round intermediate computations. Give answers in radians. Round your answers to the nearest hundredth. I am going to draw a picture, and I suggest you draw a picture every time. Pictures are incredibly useful here. Obviously, there's pictures on my little table, but the idea is that you're thinking through this as well. So here is my unit circle. I see that cosine is negative, so this is a negative x value, negative x value, which means that our lines that we're going to be looking at, there's going to be, right, some negative x value here. And then you would have that same negative x value down here. So there will be this guy here, theta 1, and there will be this guy here, theta 2. And I might just separate these drawings. That's what I'm going to do. Duplicate. I'm going to separate these drawings out. Draw a better arrow there, and so that we can talk about them separately. Theta 2. All right, the range of cosine inverse. The range is this top half of the circle from 0 to pi. This is the range of cosine inverse. Those are the angles it will spit out between 0 and pi. I'll make sure to highlight that guy over there too. Well, it doesn't matter for that one. Inverse with an E. So because this angle fits perfectly within that range, when I go to do inverse, it's going to spit out this angle here. It's going to spit out theta 1. Theta 1 should be equal to cosine inverse of negative 5/6. If you plug that into your calculator, you should get 2.56. Something to kind of keep in mind here. We talk about, so this is pi over 2, and this is 3 pi over 2. We talk about these numbers with pi's a lot, and it can help when you're doing these problems to know what these are in decimals. So pi over 2, pi over 2 is a 1.57-ish. So this is like 1.57. Pi is, of course, 3.14. 3 pi over 2 is 4.7. And then 2 pi is 6.28. So the reason this is helpful, 2.56, that does fall right in the quadrant we're hoping. So, that sometimes helps to see it in its decimal form. So 2.56, that's going to be one of our answers. 2.56. To find our next answer, we're going to need to find a reference angle, because this angle right here is going to be the same as this angle right here. And I know that if I can find that red angle, it'll just be pi plus the reference angle. So to find that reference angle, I know pi is this amount, so I take pi and I subtract theta 1, right? I have it written a tiny bit different in that table, but that's what it comes down to, right? It's going to be pi minus theta 1, which is cosine inverse of negative 5 pi over 6. Oops, not sine inverse, cosine inverse of negative 5/6. This whole thing here is the reference value, so I'm going to plug that into here. Theta 2 is equal to pi plus pi minus cosine inverse of negative 5 over 6. If you plug this into a calculator and all is right, just, and happy in this world, you should end up with 3.73. 3.73. And those will be your two answers. Oop. Yeah, my goodness. There they are. You can look, 3.73 is between 3.14 and 4.7, so we can feel good about that answer. Again, there's one of the answers and two of the answers. All right, one more. Cotangent of theta is equal to negative 1.12. I am going to, once again, I'm going to take this guy down here, erase some of his stuff, and start again. All right. So the way I'm going to start this, I need to get it into tangent because tangent is the one I have a button for. Tan inverse I have a button for. So tangent of theta is going to be equal to, you have a few ways of doing this. If you wanted, you could go on a calculator and figure out what negative 1.12 is as a fraction and then take its reciprocal. Or you could just say 1 over negative 1.12, that's the reciprocal. Either way will work. We know that the range of tangent is the first and fourth quadrant, and that it goes from negative pi over 2 to pi over 2. If tangent is negative, that means that we're looking at quadrant 1. Let's do, not quadrant 1. We're looking at quadrant 4. So tangent is negative. So that first one is going to be in quadrant 4. And then for tangent, its other value is going to be all the way on the other side of that unit circle. So if I then take this whole thing, duplicate, come on over here, delete, delete, delete. The other angle here will be all the way directly across the unit circle, and that will be theta 2. Theta 1, theta 2. The problem is when we get an angle spit out of this thing, it's going to be a negative number because it's within that negative pi over 2 to 0 range. So if it's going to be a negative number, we need to do a little bit of like math here. We need to do a little bit of math here. I need to be able to find this reference angle because once I have that reference angle, that'll be the same angle over here. And I'll be able to do pi minus the reference angle to find theta over 2. And in fact, I could write that right now, right? I could say, I know once I have that reference angle, this will be pi minus that reference angle, theta ref, or reference angle. Now, whatever angle is spit out here from, if I do tan inverse of 1 over negative 1.12, this will be a negative number. If you put it into a calculator, in fact, I probably should put it into a calculator. Let's change this to degrees, clear it out. Then let's see. 1 divided by negative 1.12 and take tan inverse of that. Oh, does this thing not have tan inverse on it? Try to use this silly calculator on the computer. Silly calculator on the computer does not work. Well, whatever it comes out to. Okay, let's pause the recording. Now my mouse isn't working. All right. So if you plug in tan inverse of 1 over negative 1.12, the number that pops out is negative 0.72885, blah, 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 blah. So it's a negative number. Ooh, come on. It is a negative number that is spit out of it. But if you take the absolute value of that, whatever that negative number is, the absolute value of it, that's the reference angle. That'll be a positive number. It'll be an acute positive number, and it will be the reference angle. So theta ref equals the absolute value of that. So to find this first angle, theta 1, it's going to be 2 pi, and then you're going to subtract out the reference angle. So you'll get 2 pi minus, we said the reference angle is the absolute value of tan inverse of 1 divided by negative 1.12. If you're going, you really need to leave these as exact values. But if you're going to do any kind of rounding here, I had said, that this thing had come out to negative 0.72885. I would keep, if you're going to use a rounded value, keep just an excessive number of decimals. Keep like the whole thing here. The absolute value of that is just going to be that number without the negative sign. So 0.7288547 is that value. So this really, if you're going to round it, I just use my absolute value button in my calculator, but not all calculators have absolute value buttons. And so 0.7288547. Plug that into a calculator if all is just and right in the world. You should get 5.55. And that does fall in the correct quadrant. It's between 4.7 and 6.28. So that's a good value to get for theta 1. We can feel happy about it. Boom. For theta 2, this is pi minus that same tan inverse deal, right? So pi minus 0.7288547. Duplicate. Oops. And if you plug that into a calculator, and again, if all is right and just in the world, you should get 3.87 as the other answer. 3 point, hold on. No, it shouldn't be 3.87. That wouldn't make sense. I think I did that. I think I did a plus sign when I calculated this. Come on, mouse. There we go. All right, yeah. So I had done the wrong sign there. It comes out to 2.41 as the second answer. That one, see, it's good I did check your work, right? Because I just realized that 3.87 made no sense because that would be in quadrant 3. 2.4 though, that does fit in quadrant 2. So I can feel good about that. And those are my two answers. I can just boop. Theta equals 5.55 and 2.41. My two answers. Again, these problems take some time. Give yourself time on this topic. Give yourself time to work through them. Even if you manage to get them all, like a bunch of them right in a row, try more, review more, because they are challenging problems. But that is it for this section for trigonometric equations, and that's it for chapter 2. So that's all. I will see you in the next chapter, section 3.1. And come on, mouse. See you then. Bye.